the x cubed term from the denominator, that's 2x cubed, and look at what's the x cubed term in the numerator, you realize that there's none. So we say it's 0x cubed. The ratio of the coefficients here is 0 over 2, which would just give me 0. So the answer is 0. Now, let's apply it to something else. So let's look at this one here. So all you do, what's the highest term in the denominator? That's 2x squared. What's the corresponding highest term in the numerator? You realize that it's 4x squared. So 4x squared here. Divide them or look at the ratios, you realize that it's 4 over 2, which is just 2 at the end of the day. So it's a quick trick as to how you can do it in multiple choice, but on a structured written paper, we'd expect you to actually divide the numerator and denominator by the highest powers and then simplify based on that. All right. So a function whose graph has no breaks in it, we call a function a continuous function. All right, so none of these make sense in mathematical contumacious, contiguous, nothing of those sorts actually makes sense, so it's continuous. All right, so you're not getting limits as to what your classmates said. But let me just double check again. Are you getting differentiation? So Reina, is it possible that you guys are going to be getting differentiation? No. All right. So based on what I have here, so you guys are getting equations, exponentials, and logarithmics, and matrix algebra. All right. So let's come over here to the next exam paper. But before I start it, I was told that the call will end soon, and because we have a limit of 40 minutes. Oh, okay. So Zoom extended the time limit, which is great, not so bad. All right. So what I'm going to do, I'm going to give you guys a quick 5-minute break between the different papers, and then we start the next one. What I'll also do, given the fact that I now know that you are only getting those specific topics, I'll try to review the topics in depth rather than just doing some multiple choice questions. All right, so I'm giving you a quick 5-minute break so you can take a breather between the two papers, and then we attempt this. All right, so I'm back. So I was looking at your course outline and I see the different topics under equations and matrix algebra and so forth. So what I'll do, as I said, as soon as I'm finished with this paper, I'll just touch a little bit at the content in your syllabus to just do a review. So let's go through it. So I'm not doing everything on this paper. I'm just doing the stuff related to the topics that were indicated rather. So I'll focus mostly on equations, exponential, logarithmics, and matrix, which would be units 3, 4, and 5 of your syllabus. All right, let's make way into this. So here we have another logarithmic function, right? And it's talking about what we call an accumulation function. So Javi opened an account with Shady International Bank in 2015. After 2 years, the balance AT in dollars in her account is AT is equal to 75,000 e to the 0.1 e to the 0.12 t, and where t corresponding to 2015. So you have to remember that t equals 0 corresponds to 2015, as what we were looking in the first paper that we did. So this first question says, what is her initial deposit into the account? So the initial deposit will be how much money you put at t equals 0. So remember, this is just asking you for A0, which is A0. So A of 0 is going to be equal to 75,000, then E to the 0.12 times 0, which if you plug in a calculator is just going to give you 75,000 times 1, which is 75,000 at the end of the day. So the answer here is 75,000. Just demonstrating how you do it on a calculator though, it will be 75,000 shift ln here, which would be the E up here, E to the 0, will give me 75,000 at the end of the day. All right, so question 2. Approximately how much money will be in the account in 2025? Now, remember when we did the first paper, we said that to find T, what we do is subtract the given year, so 2025, minus the starting year, which is 2015, and we find that T is corresponds to 10 years. So to find the amount in the account at the end of 2025 or in 2025, what we're going to do, we're going to plug T equals 10. So A10 now is equal to 75,000 E to the 0.12 times 10. Just plug that in your calculator as is. So 75,000 E here, right? 0.12 times 10. Then you get that the value is $249,008. So let's see if we can actually find that there. So the closest answer to it is 249,000. So this here is going to be A. All right, and question 3 asked you, in what year will she have 10 times her initial deposit as the balance in her account? So we know that her initial deposit was what? 75. And they're asking you, what year will she have 10 times that? So 10 times 75,000 is actually 750,000, right? So we know that 750,000 is equal to 75,000, because you want to find the time, so you just write by the function, e to the 0.12t. Now I'm solving for t here, right? So divide both sides by 75,000. I'm going to get 10 over here is equal to e to the 0.12. Well, let me not confuse this, so let me write out everything. So divide both sides by 75,000. Divide this side by 75,000 as well. I'm going to get that 10. These are going to cancel out and give me 1. So 10e to the 0.12t. Then to solve for t, guys, I need to get rid of the e here. But I need to also, like, how do I get rid of that? Essentially, what we would do is take ln of both sides. So ln 10 here now is going to be equal to what? 0.12t. Because when you take ln of e, they cancel each other and then the power will drop. So to solve for t now, it's going to be ln of 10 divided by 0.12 is equal to t. Drop that in your calculator. So as a fraction, so ln of 10 over 0.12, I get that t is 19.1 whatever. So round this down, I get that it's 19, right? So to find the year, I'm going to say 19 plus the base year, which is 2015, I get that the year would be 2034 or 35 because you'd actually run it up because it's a partial year. Closest answer is 2034. So here, that would be the closest answer. And so that would be the start. But there's something very interesting about this question. And if you ever go up to the financial management or financial math, this is what we call an accumulation function. The accumulation function is compounded continuously at a rate of 12%. So we call that the continuous rate. It's very interesting, rather. So this is a very nice question. We do it in financial mathematics, but nothing that you guys need to worry about. So they're asking about which graph responds to y here. So if you look at the function, guys, it is an exponential function, right? And if you remember me showing you all the graphs before, exponential functions will always look something like this, right? Pay attention to the domain here. The domain says that t is 0, 1, 2, 3, and so forth. So you realize that we won't focus on what's happening on the negative portion of the graph. So this portion over here, the negative portion, is going to actually be non-existent. So the graph is always going to look something like this, and it will go on and upwards from here on out, right? So let's just look whichever one actually satisfies that condition. So it's not this, the graph here shaped wrong. It's not this because this is a linear graph. This seems correct, yes. Let's check the others though. It's not this because this is a logarithmic graph. And it's not this because this is a constant graph, y equal k. So the answer here is definitely C there. So you have to remember how your logarithmic graph looks compared to how your exponential graph looks. And always, always, always pay attention to what your domain is. All right? So the domain is very important as to how the shape of the graph would look. All right, so let's move on. So the very same thing here as to what we did, the same questions repeated. So remember to write it as an exponential form. What you're going to do, you're going to take the base and carry it to the next side and push it up. So what's going to happen here when I push it up, x is going to be equal to a raised to the power of y. And then I get the answer here is e. Cool. For question 6, as we did in the last paper, what you do, we take log of both